So with that, I would like to introduce our first speaker, Dr. Glenn Miller from the University of Nevada, Reno.
The calculations that people do is looking at if you're growing, can have 120 kilograms per hectare of CBD, and current price is around $1,000 per kilogram, plus or minus. And if you do those calculations, you come up with $120,000 per acre. And people look at that and say, well, let's do 10 acres or 100 acres, and it goes up to $12 million. And we clearly are all going to get incredibly rich. I've not met any of those people yet. What I have met is people who have lost a fair amount of money because of all the problems that come in with growing hemp. Some of which are the regulatory aspects. People have had to plow around the country, had to plow hemp fields in because they were exceeded THC concentrations. In whether you're going to plant seeds, transplant female plants, or even clones, those are all quite expensive. Last year they were $1 per seed for a feminized seed, which if you plant 100,000 seeds, you can do that math pretty easily. Several agronomic aspects of how to grow plant, pests and pest control agents. Weeds are a major problem since there is no pesticides. Dr. Armbrust will discuss some of the regulatory issues there. Plants also have to be harvested and dried. There's a severe mold problem if they're not dried properly. Lots of labor is required, and harvesting techniques are not well understood. There's a lot of analytical work that needs to be done, and processing, extracting out the cannabinoids, distilling them, isolating CBD if that's what you want, and then ultimately marketing the product. So you need you got to have a farmer who knows what they're doing, got to have a chemist to do the extraction analytical work, and then you've got to have somebody who knows how to market it. There's currently no federal taxes on growing hemp that are specific to hemp. There is very high state taxes on growing medical recreational marijuana, but taxes aren't applied to many hemp farms yet. But there's several products that can come out of growing hemp. The one that's big right now is cannabidiol, CBD. But there's a bunch of other legal cannabinoids that can be marketed. That CBD is at about $1 per gram, give or take, if you have kilogram quantities. Some of the other cannabinoids you can get over $20 per gram, but they require usually some chromatographic techniques that are expensive in themselves. There's people that are producing hemp seed oil that you get the seed. It's just pretty much like any seed oil, triglycerides primarily, very low CBD or any cannabinoids. Also, fiber is now people are starting to look at hemp for fiber, for paper, for clothing. And it's some fairly nice clothing. I've felt some of it. If you collect the right kind of fiber, that can be good. And ultimately, once you extract the hemp, it's a potential livestock feed, although that's currently not allowed. Some of the cannabinoids all start with the precursor CBGA, and that from that CBGA you can have strains that will primarily go to THCA synthase to make THCA, or CBDA synthase to make CBDA. These are both carboxylic acids that have no physiological effect really at all, and they have to be decarboxylated just simply by heating. It's quite an easy process to decarboxylate to give you THC or CBD. It's important to note that both CBD and THC is not legal except in a very well-regulated state. CBD, on the other hand, is legal. It is no longer classed as a drug. But the problem is if you're going to find a strain that produces exclusively CBD, it's hard to do. And right now the standard for THC is less than 0.3% by dry weight. Some of the other cannabinoids that are of particular interest, the CBG, which is a decarboxylated starting material. A lot of people are looking at that now. It has a higher value than CBD, but there's going to be a lot of growers. There's going to be a glut on the market probably this year. Another one, CBN, is an oxidation product of THC, and essentially remove 4 hydrogens to aromatize the the molecule. And then there's CBC, which is a different cyclization than THC that there's a lot of interest in now. And you can find strains that have higher concentration of these. Neither one of these, CBC or CBN, can be crystallized out of hemp extracts because there's not enough quantity. And but CBD can be crystallized out of hemp extracts or distillate. A couple of things about the Farm Bill of 2014. It legalized hemp by saying it cannot have more than 0.3% THC. And they mentioned exclusively delta-9 tetrahydrocannabinol. And it turns out the plants don't make delta-9 tetrahydrocannabinol. They make delta-9 tetrahydrocannabinolic acid, which has to be decarboxylated THC. So farmers said, hey, this is great because there's really no hemp plant that has hardly any THC in it. It's all THC, THCA. And so there was essentially no failures, regulatory failures for hemp during 2014 to 2018. 2018 Farm Bill defined industrial hemp as no more than THC, 0.3%. But then they said the term THC includes all isomers, acids, salts, and isomers of tetrahydrocannabinols. It includes delta-8 and then THCA, which is a carboxylic acid. And what that did is essentially meant that you had to calculate your THC concentration based on all the THC acids, salts, isomers, and decarboxylated products. And that's where there has been several crops now that have failed the THC test. One of the big issues now is how to sample these plants, stalks and roots and some of the branches contain very, very little THC. Most of the THC is found in the buds and some in the leaves. And so depending on how you gather the sample can have a major impact on whether that crop is going to be legal. There is a question of laboratory uncertainty, and as you'll see later on, that there is a plus or minus at least 10% uncertainty when you take samples from various plants. Then right now, several farmers across the country have had to have their crops destroyed because of this violation of 0.3%. There is a lot of heterogeneity issues in the field also. These are not, the genotypes of plants usually are not very pure. And so you get a fairly high variability within a field. And so there's a question of how many samples you should take to get a actual representative sample in the field. And that's not really well understood yet. And it really depends on the strain of hemp that you're growing. And when you do get a result showing concentration of cannabinoids in a plant, you should really have to know exactly where that sample came from and what it represents, because it can vary all over the place depending on how that sample was actually taken. Just a quick comment on state regulatory issues. This is a fairly new industry. There is regulatory programs in many of the states. Now, my state of Nevada has one that works reasonably well, but there's not much consistency among the states that I've seen. That probably will improve over the years, but it's fairly inconsistent at this point now. Nevada regulates hemp through the Nevada Department of Agriculture. There are no taxes on hemp for some obvious but not justifiable reasons. Medical and recreational THC marijuana is regulated by the Department of Taxation in Nevada, which is an agency that I don't think cares much about human health. They do want the tax revenue, which is not trivial. It's a big deal, but that's for the THC strains of cannabis, as opposed to CBD strains that are involved with hemp. There is no regulatory oversight right now for any hemp for pesticides, metals, terpenes. The only regulatory requirement is you can't have more than 0.3% THC in the total THC in the plant, dried plant, and that's probably going to change at some point. I'm not sure. There's other questions how the other states are going to look at this, but I think that there will be, since it is used as a food product or a nutraceutical or whatever you might call it, it probably will be regulated more so for pesticide content in the future, although I hope it's regulated differently than marijuana is, because it's quite an expensive proposition. This is an example of a hemp we grew at an agricultural experimentation. This was a cherry wine, which is a fairly common hemp product. This did not violate the THC standard, but the concentration of CBD was on the order of 7 to 8%, which is relatively low. But it was 0.2, I think, percent THC in the samples that we had run. Another picture of a close-up of a hemp plant. They look just like marijuana. You can't tell, at least I can't tell, a difference between medical recreational marijuana and hemp. Growing conditions for hemp are pretty easy. Nevada grows at hot climates, grows in cold climates, has a 80 to 120 day growing season depending on the strain. There's very little indoor growth of hemp. All the medical recreational marijuana has to be grown indoors now, but it just doesn't make sense to grow it with all the costs associated with indoor. So it's grown outdoors, and it's generally considered a low water requirement crop. And that's why a lot of farmers in Nevada are looking at it, because it takes much less irrigation than water does. But it seems to grow fine, but it'll grow fine in most states of the union. This is a farmer we're working with, had built a greenhouse to grow plants for transplanting. These was the seeds that were purchased. They were feminized seeds. Are actually quite productive. They germinate. At least the seeds he had germinated very well. And transplanting these small plants, we used basically a transplant device similar to tomatoes or any of the crops that are transplanted nationally. A couple of people sit on the behind end of the instrument and basically drop in plants into holes that covers them up, and they seem to grow fairly well. Plastic can be laid down. There's both irrigation pipe and plastic, which helps with the weed problems considerably. But it works out fairly well. You can either easily go through, plant 100 acres in a couple of weeks if you have the seedlings to go with it. One of the issues that comes up with growing hemp that pretty much everyone recognizes is if you have strictly female plants, you'll get quite a bit more higher cannabinoid content. All the marijuana growers know that, and so you either use clones of females or they use feminized seed, which is a process that you treat the seeds and you can get rid of the male plants and have only female plants. And you can buy feminized seed. They're the ones that are $1 a piece. You can use clones of females, or you can plant, and this is not recommended at all, you can plant regular seed that has half male, half female, but you have to walk the fields to remove all the males, which is effectively impossible unless you're dealing with a garden-sized plot. And it's hard sometimes to identify the males without getting very, very close to them. So if you've got 10 acres, it's almost impossible to get all the males. If you don't get the males out, one male plant can pollinate a whole lot of female plants, and your CBD concentration is going to go way down. The other thing that's going to be an issue at some point is when you have neighbors that are growing hemp for fiber or hemp for oil seed. They don't have to get rid of the males, and if there's pollination, it's generally a 5 mile barrier is what people think might be far enough apart, but that is going to be a problem as different types of hemp are grown. Most of the hemp now is grown for CBD, however, because that's where the money is. When to harvest? That's that's I think people will recognize that as an important issue because if you haven't got good ratios of CBD to THC, you want to obviously have the CBD as high as you can get it, but the THC, total THC, less than 0.3%. And there's more data coming out now on some of this. We've looked at this issue, the ratios of THC to CBD, do they go up or down or remain constant during times as you approach a harvest? And then how variable is this ratio in total CBD within a plant or plant to plant? And that's one that needs to be understood also. We did some work on, we grew a variety called Suver Haze at the experiment station here. And we measured CBD concentrations at 3 different plants over a period of about 6 weeks. And from the time that it was starting to mature to harvest. And we started about 5% CBDA when we started sampling. And it got up to close to 18 to 20% CBD, which is really a high CBD. We actually just are reporting CBDA concentrations because there wasn't much CBD in these plants. It was all CBD A or THCA. And as you can see here, the concentration of THCA was measured also. And we know now that the concentration of 0.3 is the limit. We went well over that, over 1% in some cases of THC concentrations. So then we looked at the ratios of those, and the ratios were the CBDA to THCA were remarkably constant throughout the growing season. The average, there was no discernible trend on those ratios, and the ratios were about 19 to 20 of the 3 plants that we looked at, and they were amazingly consistent. Didn't seem to increase or decrease over the period. There's some variability in the data. You can see plus or minus 10% certainly in how these when the samples were taken. But if we go back to here, it says that we should have started harvesting in early September to keep the THC concentration. These are just buds and flowers that we sampled. And so, so it could have taken a little bit longer because the state of Nevada, when they do a regulatory check, they actually will give you some stalks and branches in the analysis, and so you can generally get away with somewhat over 0.3% in the THC. But in fact, we had to plow under, or we had to destroy about $20,000 we were hoping to use for additional research purposes, because the average, the THC concentration in 3 samples was 0.32, 0.36, and 0.37% THC. And they made the determination that that was no longer hemp, but they classified as non-hemp, and therefore it had to be plowed under, which kind of hurt. As we watched the front end loaders mix our $20,000 of buds in with a pile of manure. But the genetics of the plants are critical. And again, there's many examples where expensive crops were destroyed. And research in New York at one of the universities there indicated that genetics of the strain are the dominant factor, not environmental growing conditions. And that's an important consideration, because people have said that if you stress hemp, you get higher THC concentration, which appears not to be the case. But then the other factor is exactly who's doing the sampling from the regulatory agency and how much of the stalks and branches they're including. The analysis is actually fairly simple. When we ever get a sample, and we'll homogenize the sample, mostly by just chopping it up. And then we take a gram of the homogenized sample and 30 milliliters of ethanol and macerate for 1 minute in a tissue miser, just a simple device. And we select another 1 gram sample for dry weight determination. The extract we filter through 0.45 micron filters, HPLC analysis with a UV detector. There's a detection issues are never really present. It's sometimes the concentrations are higher than the UV detector will allow. We're doing 25 microliter injections. Either GC or HPLC will work, and there are both regulatory acceptable, but the GC will decarboxylate the samples in the injection port and will give you a total THC concentration. I'm never quite sure whether that's quantitative or not, but I think everyone is using HPLC with the reverse phase column, and methanol and acetylnitrile with a small amount of formic acid to keep the acids protonated. We use a Phenomics column, and the separations are generally fairly good and easy. You can see CBD in the fourth peak in, and CBDA comes a little bit after that, and then THC, delta 8, delta 9 THC, and then THC after that. And some of the other cannabinoids are there present also. The Sapalco and ResTech all have columns that work fairly well, and some of these separations they're not terribly difficult to do. Some of the analysis, just to show you what one of the labs in Reno, some guys I've worked with over the years, produce will tell you hemp analysis. They'll give you a total potential THC, and that's THC times 0.877 to give you basically a molar conversion. And then the total potential CBD. This is a low CBD sample, but also a low THC sample. Here's one that's 0.9% THC and the total potential CBD. Both THC and CBD rose, and this one is legal. And here's another one that's not really hemp anymore, even though you have close to a 10% CBD, you have 0.4% THC. And so this is probably one of the major problems with growing hemp right now, is making sure you have the strain that will work. Harvesting is also an issue. Hand harvesting is probably the best way of doing it. It takes a lot of people to do this. You've got to harvest it and dry it in large sheds. Hand removal of vegetation to produce the flowers and leaves for extraction. There are some increasingly common commercial methods. They've been tried here, not terribly successful. It's hard to get wet biomass off the stalk. There may be that technology is probably coming around, though. Probably there's people that are now looking at machine harvesting and chopping the entire plant into small pieces and extracting that. What that does is it's a lot less expensive. You can do it with basically a basic harvester. But what it does is it dilutes out the CBD, so the extraction is going to be more expensive. Industrial dryers are commonly used. Again, they're expensive. And then when you dry it, odor may be an issue if you're near people. In our lab, we did some drying of hemp, just a few pounds of hemp, and we got complaints from people upstairs about the odor. What were we doing in our lab, extracting marijuana or what? And so odor can be an issue. Molding is an issue if you don't dry it successfully, but then oxidation is also an issue if you're not careful and you over dry it and you allow oxygen to get in. CBD, all the cannabinoids are actually very easily oxidizable. So you have to be careful. Harvesting from harvest to drying to extraction should be as short as possible. You can lose 1%, as in 10% 1 month, 9% the next, 8% as an anecdotal rate of, I've heard that number from a few people, but it's clear even on the material we harvested this fall in October, we've got about half to 2/3 of the CBD we had in it originally. Can store it cold or under nitrogen. It'll probably likely decrease the cost or the loss of CBD, but it's still a problem. The extraction produce a product that is generally brown, has a distinct marijuana odor if you extract them with a solvent. But that extract concentrate once you get rid of ethanol. And that's an expensive process because there's so much ethanol you use. So if you're in a big production, you generally need a thin film evaporation system, and they're quite expensive. But then you have to decarboxylate the extract to get the CBD, and then you distill that generally under a high vacuum. And then if you have a distillate, you can sell that directly in some cases. But if you want to crystallize the CBD, it's simply dissolve it in hexane and cool it down, and that's a fairly easy step. THC won't crystallize very well at all, but CBD seems to crystallize quite nicely. And you can get these isolate, what's called the isolate, which can be as pure as you want to recrystallize it, but you can get it easily 99% CBD crystals. And then you market those as either CBD or distillate or whatever you might want to do. Generally speaking, the extraction product from the concentrate is pretty dark, and it contains a bunch of other things that you may or may not want to have. The cost of extraction, if you're using ethanol, can be close to $750,000 if you're doing a large production scale. And you can use supercritical CO2. I don't see any reason to use that. Public seems to like it, but it's for medical marijuana because it's quote unquote solventless, which is not completely correct. But it isn't really as efficient as ethanol and quite a bit more expensive. Solvents are generally the case. There's a lot of butane extraction for medical recreational marijuana. That's really not a good idea for scaling for hemp. Base extraction has potential, although that's not proven yet. Most of the people are using ethanol, cold ethanol, minus 30-degree ethanol extract for 10 to 30 minutes. Then you remove the ethanol and ultimately concentrate that. And then again, back in the distill it on, you've got a product that you can sell. Ethanol is relatively inexpensive. It's obviously a very low toxicity, and it works because of the trichomes that are on the leaves are very close to the surface and can be extracted efficiently. You can get 80–85% extraction of very cold ethanol for a short amount of time. It does work reasonably well. Bunch of other analysis that can be done, but this is all for medical marijuana now. I don't think a lot of these are going to be required for hemp for a while. Some may, but that's probably going to be restricted to state regulation. Oilseed hemp is another. I just want to go through and mention that can be grown. This is mostly just triglycerides. There's very low THC. But some people seem to like oilseed hemp oil. It is fairly expensive. You can make pretty good money. I know there's a Colorado group that is looking seriously at oilseed hemp, but it's not. I don't think it's profitable as CBD hemp at this point. Just a comment about hemp fiber. There's a lot of work now going on here and elsewhere to look at if you can take hemp that is primarily derived for CBD and taking the stalks to see if you can't get a hemp fiber out of them. It's hard. I've not done any of that myself. I know there's a fair amount of talks on it, but it can be a fairly good product. And with that, I think I'll turn it over to Dr. Armbrust. But I think hemp has got a pretty good future, but there's enough difficulty in growing that is different than other crops, and it needs to be evaluated carefully. Dr. Armbrust.
Glenn, thank you very much for that introduction. I'm going to pick up and run with this mainly from the side of pesticides. And the basis of this is that hemp, like any other agricultural commodity, is a crop. And like any other agricultural crop, it will get pests, and people would like ways to be able to control these pests. And as many people that are on this call are aware of, since Colorado first legalized marijuana back, I believe it was around in 2012 or 2013-14, when it became actually legal in Colorado, there's been a basis for how to do this. And so one of the things that this is really brought up is the question again, is the roles the states play and the roles that US EPA play, and more importantly, where a lot of the national associations that represent these particular agencies come into play too. And that's what a lot of people aren't familiar with. So I'm going to kind of just roll through this a little bit. I'm not going to get heavily into all of the questions about how you go about registering a pesticide or some of these other aspects of it. And to be perfectly in full disclosure, I was much more up on this about three to 4 years ago. I haven't been working with this within the last few years. And so some of this most of the things I'm going to be talking about are staying the same, but this is a very, very dynamic and ongoing process, especially related to hemp and marijuana. But who are the players in pesticide registration? Well, the US EPA is responsible for the federal registration of pesticides, but then the individual states come in. And after you have an initial federal registration, states have their own registration processes, and those vary considerably depending upon the state you're in. States primarily have responsibility for the implementation and enforcement under FIFRA for pesticide use under FIFRA. And really what this is this recognizes the primacy of states once the product is originally registered. Now, we obviously have 50 different states and then the additional US territories, and everybody doing their own thing can seem a little chaotic, and it is to a certain extent. And so there was recognized a number of years ago that there was a lot of value in having forums, more or less, where these different agencies could all talk together. And that was really the genesis of the Association of the American Pesticide Control Officials. And this represents federal, state, territorial, and provincial pesticide regulatory officials that are involved with the enforcement under FIFRA. Federal agencies actually aren't members under APCO, but they heavily are represented and are involved with this. Under APCO, the blanket of APCO, you have what's referred to as SFIREG, which is the State FIFRA Issues Research and Evaluation Group. And this is really the primary platform between both EPA and state regulators to resolve pesticide program and policy challenges. And this has actually been a very, obviously with marijuana and the potential use of pesticides in marijuana, this group has played a larger and larger role. So how do the states typically work with EPA through these? Well, with full SFIREG, state representatives, there are full representatives from each of the 10 EPA regions, and they're generally all APCO members. And there are two working committees under this, both the Pesticide Operations and Management Committee, which has responsibility for registration, certification, and enforcement issues, both of national and regional importance. And then the Environmental Quality Issues Committee, which deals a lot of the technical aspects of pesticide programs. And they handle issues, things like endangered species, risk assessments, water quality, and so forth. These particular groups are all, again, very important. These forums are very important. These are all public, open to the public. They're all published in the Federal Register. They're usually very well attended by some of the pesticide registrants, representatives from some of the companies, but you also do get a variety of other individuals as well. And so if you want to be involved with some of these particular groups, these again are very good forums to see how some of these processes actually all work together. EPA's role in this is, again, EPA grants licenses and registration to sell or distribute pesticides, and then after that, they then fall back to the various states. Now, there are various types of registrations, and again, this is just a highlight of these, but you've got new pesticide registrations or uses. Those are what are referred to as Section 3 registrations. There are emergency exemptions that can come up where if there is the situation comes up in a particular state, you have a novel pest pressure and there is a need to control a pest for which that is novel on a particular economically important crop where there isn't something available for it, states may issue Section 18 registrations. And request Section 18 registrations, which is again an emergency use just to deal with those particular situations. There are experimental use permits that are available too that allow limited use of particular pesticides to see if they will work, and these especially become important for a lot of specialty crops. But then there are also state special local needs registrations, and these are referred to as 24C registrations. And these actually become important for a lot of states where states are wanting, after you have an initial registration, and states are willing to carry a specific type of registration on their own. And I'm going to talk a little more about that in a minute. EPA also establishes pesticide tolerances, or maximum residue levels, for the maximum amount of pesticide that can be in or on food or feed. And this becomes important also when you start getting into marijuana and hemp. So what are these state special local needs registrations? FIFRA specifies that states can choose to register an additional use of a federally registered product if the for a new use to meet a special local need. Now, then the state has to actually carry this registration, and they have to develop the data for it. The EPA will review these registrations and may disapprove of the registration. If the EPA does not disapprove, and that language is important, the state's registration of the use under the Special Local Needs Program and Special Local Needs registration may continue. Special Local Needs registrations, they permit generally just the distribution and use for the only for the registering state. And then again, using labeling that's approved by the state for that particular crop. Now, a big part of this is that you have to still develop a pesticide tolerance for it. And so all pesticides must have tolerances for the crops they're going to be used on. These tolerances are correctly so risk-based, and they're based upon the labeled use and rate, and also they incorporate exposure and toxicity. So EPA issues the tolerances as part of the initial registration, and they'll tend to, and they will either approve or choose to not disapprove of proposed tolerances for special local needs. So the system kind of works, right? Except when you get into the case of marijuana. And the issue that you run into here is that where does cannabis fit with all this? Well, cannabis is an agricultural crop, as I mentioned earlier. Like other crops, it has pest pressures, and growers are going to want to control the pests. Federally, cannabinoids are Schedule I drugs, and cannabis is still an illegal crop. Now, I have to correct this. This is actually an older slide. Cannabis as hemp is actually legal under the Farm Bill, especially in 2018. And cannabinoids are actually not Schedule I drugs anymore, except for THC. Most states have chosen to legalize or decriminalize it in some form, but at the bottom line, at the end of the day, and having somebody who spent quite a number of years at the state level dealing with this, I can tell you growers will tend to use something either legally or illegally if their business is threatened. Again, as I mentioned at the bottom, industrial hemp is now legal under the 2018 Farm Bill, originally 2014, and then is modified in 2018. So again, the current status in EPA's views, and I haven't spoken to EPA in the last couple of years, but I'm assuming this is still their views, is that generally the label is the law. Marijuana is not federally legal. It's still an illicit drug, and it doesn't fit into generally any crop category, either spice or vegetables. And they've had continual concerns that the use of unregistered pesticides on marijuana, or hemp for that matter, could have unknown health consequences, as no pesticides have undergone the risk assessment for these. The current status of this under hemp is that hemp was legalized as a crop under the 2018 Farm Bill, and so its hemp and its derivatives were removed from the Controlled Substances Act. EPA did approve 10 pesticide products for hemp production this last December. All of these are biopesticides except for one conventional product, and these products are listed in the table below, and they include azodactrin, which is actually a component of neem oil. Neem oil is just a general extract of neem seeds. You've got soybean oil, garlic oil, capsaicin. I am not going to try to pronounce the 3 bacterial strains of materials that can also be used, because I will completely slaughter the names. And then potassium salts of fatty acids, which is actually considered a conventional pesticide. So these are the 9 products that are currently approved for use as of December 2019. And with that, we are going to open this up for any questions.